Hello, I'm Zaidan Kazur with Emerson Process Management. I'm the Bailey System Transition Consultant in our Modernization and Migration Group. I'm going to go over and demonstrate two of our solutions to transition Bailey DCS systems to Delta V and PlantWeb. Delta V Connect for Bailey and Flex Connect solution for Bailey systems. Emerson has invested a lot of time and money in creating these solutions to help customers transition their legacy DCS systems to Delta V while maintaining their investment in these systems and helping them move to the latest digital technology with embedded advanced controls, digital buses, and so on. First, we'll start with Delta V Connect for Bailey. Here's a system architecture showing the Delta V system connected to the Bailey system. We have a Bailey network, data highway, whether it's Infinet or Plant Loop, and we have our Delta V system on the top. We actually take a Delta V application station, run a Delta V interface driver to the Bailey system on that app station, and connect it to the Bailey CIU on the Bailey system network. We can do that using serial or SCSI connection, and we can have that application being redundant. On the Delta V network, then you see the Pro Plus, which is the engineering workstation for the Delta V system, and operator station as needed. Now, looking at the hardware in the cabinet that we have here in this demo, we have the Bailey CIU, which is in a Net90 rack or Infi90 rack. It's a CIU01 with the termination panels, the TCL, and a TMF. We actually take our application station and connect it to the serial port on the termination panel for that CIU. And that's all we need for the Delta V Connect for Bailey solution, because our application station connects to the termination panel of the CIU, and it will give us access to all the data that is in the Bailey system. In this case, we have a process control unit, NIS NP pairs, and one MFP controller. This is where all our configuration resides, and that we have access to it from the Delta V Connect Bailey application station. Once Delta V Connect for Bailey is loaded on your Delta V system under the library and under the module templates directory, we have a new folder called DVC-Bailey. This folder actually has module templates that are created specifically for the Delta V Connect Bailey interface. And if you look at these templates, they are referencing the Bailey exception report blocks. AIL is a Bailey exception report block, DANG, DADIG, device driver, MSTD, RCM, station, text block, and so forth. So we do have a template created for each one of the Bailey exception report blocks. That's how we get access to the data on a Delta V station. We create shadow blocks for each one of the exception reports off of the Bailey data highway. Now, one template in particular that's called IDB has the IDB block in it. This is the interface definition block that we want to look at in details. We open it with Control Studio, which is the configuration engineering environment within Delta V. IDB, this is the block that sets up the communication between Delta V and the Bailey systems. Has a number of parameters, but in particular, there are a couple that we are interested in. The first one being the scheme. This will set up your interface, whether it's a single interface, with redundant channels where we can actually connect to both ports on the CIU, whether it's dual interface where we can have one application station connected to two separate CIUs, or whether it's a simulate interface. In this case, we are using a single interface. One other parameter is the port A and port B. If we are connected to one serial port, we do get about 300 points per second. If we're connected to both ports, we have about 500 points per second. The main thing that we need to set up here on this parameter is the baud rate, which should match the CIU baud rate on the Bailey system. So if we have a second port, we would configure port B the same way. We save this block and download it to the Delta V application station that's running the interface. Well, let's take a look at another module template so we can get an idea about the different parameters inside them. We'll take a look at the station, which really matches the station block in the Bailey system. Open it with Control Studio. Okay. As you see, there's only one block in this module template, just like the rest of them. We have a shadow block to match the exception report on the Bailey system. And all we need to set up in this block is really the address of the Bailey station block where we're going to get that data from. One being module, we have to set up the module on it, node, which is the PCU equivalent, ring, which is the loop or the ring, then block, which is the block address inside that module. Now, after we've done the configuration for the interface, let's take a look at the Delta V operator environment. Let's take a quick look at the interface. As we mentioned earlier, the module templates that we have provided in the library, they all have faceplates associated with them. This is the faceplate for the interface definition block or the IDB block. And as you can see, it tells us that we have the primary port active. In this case, we only have one connection to the CIU. It is online. The secondary port is not being used. At the same time, it provides us information on the CIU that we are connected to. It's an ICI 01 in this case, and it's ring 1 node 2. And it is a time sync master. We do have time syncing enabled between the Delta V system and the Bailey system. Besides that, we do get some information about the data that we are transferring between both systems, some of the exception reports and the messages and so forth. So it's very, very useful information to the operator to see how the interface is working and performing. Let's take a look at some other screens in this case. Here's one where we are making spaghetti sauce. Just to give you an idea, we have configured modules here for each different type of the Bailey exception report blocks. In this case, I can click on this. This will open up a faceplate. It happens to be a device driver. It tells me I am permitted to operate it. One piece of information that's good here, it tells you you're online, which means the interface is working and operational. If it says offline here, that means I know there is something wrong with the interface. I can go ahead and open. This, in fact, opens all these valves to add the ingredients for our sauce that we are making, all the dry ingredients. Now I can click on this. This will open up the faceplate to add the tomato sauce, this pump. These faceplates, as you can see, are similar in the look and feel to the Bailey displays. They will provide you, the Bailey faceplates, they will provide you all the information that is important to the operator to control this PID loop. We've got the manual, the modes, whether it's auto manual, or you can change it from here. We have the arrows to change the set point and the control output based on the mode. So for example, right now we're in the manual mode. If I hit auto, it's gonna go to auto mode. And it opened the pump, it started the pump, and now we're starting to put in some tomato sauce. I can go in and change the set point, either by clicking on these arrows to go up, or I can actually take the set point here and just drag it up to put in a new value. We provide additional buttons on these faceplates to give us access to additional data. For example, we provide a detailed faceplate that's accessible from this faceplate that will give us the parameters for that particular point, the high and low and so forth, which are tunable from this screen too, and provide us the information on the PID block associated with this station. As we know in the Bailey system, we got a station block and a PID block that are separate. The PID block does not have a faceplate associated with it, so we provided that information on this particular faceplate to allow the operator to look at the PID block and actually tune its parameters from the screen too. In addition to that, we do provide the capability of enabling and disabling alarms from this screen, provided the operator has that access level. Okay. Some of the additional buttons on this faceplate are one that will take us to the primary display, which we are on right now. The other one takes us to the trend, which in the Delta V system, every point has a trend associated with it, built in automatically, so you do not have to configure that separately. And in this case, we've got this trend, which is really the current real-time trend. You've got the process variable, the set point, and the control output trend in this case. Now, we can go to the Control Studio, which is the engineering environment to configure this particular point. Let's say you do have a problem with it, you want to change the configuration, you can do it from here. Or we can go to a process history view where we can view the historical data that's being saved along with the alarms and the events. Now we finished talking about Delta V Connect for Bailey. Let's talk about Flex Connect solution for Bailey systems. According to this architecture drawing, as you can see, we leave the Bailey termination panels in place and we replace the cable that used to go from the Bailey termination panel to the Bailey I/O cards with a custom cable that we made up, brings it into a Flex Connect breakout panel. Then from that breakout panel, we wire into the Delta V I/O cards. What this does, it saves the field wiring, so you don't have to touch all your I/O wiring because this reduces a lot of the risk and a lot of the costs associated with that. Now, as you can see here, what we've done in this cabinet, we have a Bailey termination panel that we left in place. This happens to be an analog input card termination panel. This custom cable goes to the Flex Connect I/O card or I/O panel that we created. Then from there on, we take a cable up to the Delta V I/O cards. In summary, let's talk about the transition options that we offer you to transition your existing Bailey system to Delta V. Delta V migration options address obsolescence, high maintenance costs, and increased functionality needs. Delta V Connect for Bailey is an easy and seamless migration path for Bailey consoles, and to make your transition easier, Emerson offers conversion services to automatically convert your operator displays and your console database. Flex Connect solution for Bailey saves you time and money by easily migrating your controls and I/O while leaving your field wiring intact. Now, if there's an interest in any of these solutions or other solutions that we offer to transition the Bailey systems to Delta V, we'll be more than happy to come out to your site, do a demonstration, and talk about your particular system. And we also offer services such as consultancy and system life planning. Thank you.